Preparing for a prompt engineering interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share. And drop a topic request in the comments. Question 1. What does a prompt engineer do, and how is it different from a traditional software engineer? A prompt engineer designs inputs that make AI systems produce reliable, useful outputs. I treat prompts like product logic. I define the task, constraints, examples, output format, and failure handling. Unlike traditional software, behavior is probabilistic, so testing and evaluation matter heavily. The role also involves understanding users, model limitations, safety risks, and integration points. Good prompt engineers bridge language, product thinking, and engineering discipline. While answering, focus on prompt design, model behavior control, evaluation, iteration, domain context, collaboration with product teams, and how prompt engineering complements software engineering rather than replacing it. Question 2. Explain zero-shot, one-shot, and few-shot prompting with examples. Zero-shot prompting asks the model to perform a task without examples, such as classify this review as positive or negative. One-shot adds one demonstration, and few-shot provides multiple demonstrations showing the expected pattern. I use zero-shot for simple, familiar tasks, and few-shot when formatting, tone, or edge cases matter. The examples should be diverse, clean, and representative. Poor examples can anchor the model incorrectly and increase token cost unnecessarily. Make sure to cover what each technique means, when examples improve performance, risks of biased examples, token cost, and how example quality affects model consistency. Question 3. How would you design a prompt that consistently returns valid JSON? I start by giving the model an exact schema, required fields, data types, and a strict instruction like return only valid JSON. I include one compact example and explicitly forbid markdown or commentary. In production, I do not rely on instructions alone. I validate the response with a parser or schema validator. If parsing fails, I retry with the error message or use structured output features. The key is combining prompt clarity with programmatic enforcement. In your answer, talk about schema definition, explicit constraints, no extra text, examples, validation, retries, structured output APIs, and defensive handling when the model violates format. Question 4. How do you evaluate whether a prompt is good? A good prompt is measured by outcomes, not how clever it sounds. I define success criteria first: accuracy, completeness, format compliance, tone, safety, latency, and cost. Then I test against a representative dataset with normal cases, edge cases, and adversarial inputs. For subjective tasks, I combine human review with rubric-based scoring. I also keep regression tests so prompt changes do not silently break existing behavior. Be sure to mention task-specific success metrics, golden datasets, human review, automated scoring, regression tests, latency, cost, safety, and performance across normal and edge cases. Question 5. What techniques do you use to reduce hallucinations in LLM outputs? Hallucinations happen when the model fills gaps with plausible text. I reduce them by grounding answers in trusted context, asking the model to cite sources, and instructing it to say when information is missing. For factual workflows, I prefer retrieval, tools, or database lookups over memory. I also constrain the answer format and scope. The best practice is not just saying don't hallucinate, but designing the system so guessing is unnecessary. While answering, cover grounding with retrieved context, requiring citations, instructing uncertainty, limiting scope, verification steps, tool use, confidence handling, and avoiding prompts that invite unsupported speculation. Question 6. How do system, developer, and user messages influence model behavior? System and developer messages define the assistant's operating rules, while user messages describe the immediate request. In a well-designed application, high-priority messages set identity, safety boundaries, tools, output rules, and domain constraints. User input should not be allowed to override those rules. I separate stable instructions from dynamic task content to reduce conflicts. This hierarchy is important because prompt injection often tries to smuggle higher priority instructions through ordinary user text. Make sure to cover message hierarchy, instruction priority, separation of policy from user intent, persistence across turns, conflict resolution, and why role design matters in production applications. Question 7. What are temperature, top P, and max tokens, and how do they affect prompt results? Temperature controls randomness. Lower values make outputs more deterministic, while higher values increase creativity. Top P limits sampling to the most probable token mass, giving another way to control diversity. Max tokens caps response length and protects cost and latency. For classification, extraction, and JSON, I use low temperature. For brainstorming, naming, or creative writing, I allow more variation. These settings are part of prompt design because they shape behavior as much as wording. In your answer, talk about randomness, diversity, determinism, completion length, cost control, use cases for low versus high temperature, and why decoding settings must match task goals. Question 8. How would you write prompts for a retrieval-augmented generation system? In RAG, I prompt the model to answer only from retrieved context and to state when the context is insufficient. I clearly separate instructions, user question, and retrieved passages, usually with delimiters. I ask for citations or references to specific snippets when accuracy matters. The prompt should discourage using outside knowledge unless explicitly allowed. RAG quality also depends on retrieval, chunking, and ranking, so prompt engineering cannot compensate for irrelevant context. Be sure to mention grounding answers in retrieved passages, quoting or citing evidence, handling missing context, separating context from instructions, chunk relevance, and preventing unsupported claims. Question 9. What is prompt injection, and how would you defend against it? Prompt injection is when user or retrieved text tries to override the application's intended instructions, such as ignore previous rules. I defend by treating external text as data, not instructions. I use clear delimiters, strict system rules, tool permission checks, and allow listed actions. Sensitive operations need confirmation and server-side authorization. I also validate outputs and monitor suspicious patterns. The main principle is simple. The model should never be the only security boundary. While answering, cover malicious user instructions, data context separation, instruction hierarchy, allow listed tools, output validation, content filtering, least privilege, and not trusting retrieved or user-provided text. Question 10. How do you manage limited context windows in long conversations or large documents? Context windows are finite, so I manage them deliberately. For long documents, I chunk and retrieve only relevant sections. For conversations, I keep recent turns plus a compact summary of durable facts, decisions, and user preferences. I avoid repeatedly sending bulky instructions unless necessary. Important details should be structured, not buried in prose. The trade-off is that summarization can lose nuance, so critical facts may need explicit memory fields or citations. Make sure to cover summarization, chunking, retrieval, memory policies, prioritizing recent and relevant information, removing stale context, and avoiding token waste from repeated instructions. Question 11. How do you prompt a model to use tools or function calls effectively? I describe each tool by its purpose, required inputs, limitations, and examples of when to use it. The prompt should tell the model to call tools for fresh, factual, or system-specific data instead of guessing. I keep tool schemas strict and validate arguments before execution. If a tool fails, the model should handle the error gracefully or ask for clarification. Good tool prompting turns the model into an orchestrator, not an unchecked executor. In your answer, talk about tool descriptions, input schemas, when to call tools, when not to call them, error handling, validation, and separating reasoning from final user responses. Question 12. What makes a good prompt for image or multimodal models? For image generation, I specify subject, composition, lighting, style, camera perspective, mood, and constraints. For image understanding, I ask focused questions and define what evidence to inspect. Multimodal prompts should reduce ambiguity. Instead of make it better, say increase contrast, keep the product centered, preserve the logo. Reference images help, but constraints still matter. I also include negative requirements when needed, such as avoiding text artifacts or distorted hands. Be sure to mention visual detail, composition, style, constraints, negative instructions, reference images, ambiguity reduction, and differences between prompting for image generation versus image understanding. Question 13. When is role prompting useful, and when can it become harmful? Role prompting can help set tone and domain expectations, like act as a senior tax analyst or respond as a friendly onboarding coach. But vague personas are weaker than clear task instructions, constraints, and examples. A role can also create false authority if the model sounds expert without evidence. I use roles lightly, then specify audience, output format, assumptions, and source requirements. Concrete behavior beats theatrical identity every time. While answering, cover personas, domain framing, tone control, over-reliance on vague roles, false authority, safety concerns, and replacing generic roles with concrete task instructions. Question 14. How do you choose examples for few-shot prompting? I choose examples that represent the task distribution, not just the easy cases. Each example should demonstrate the exact format, level of detail, and decision boundary I want. I include edge cases when they commonly fail, but I keep examples concise to control token cost. Label consistency is critical because the model imitates patterns. I test different example sets because ordering and wording can change outputs more than people expect. Make sure to cover representative examples, edge cases, ordering effects, label consistency, concise formatting, diversity, avoiding leakage, and testing whether examples improve results versus increasing cost. Question 15. How would you manage prompt versions in a production application? I manage prompts like production code. They should live in version control, have owners, review history, test cases, and deployment environments. Every prompt change should be linked to evaluation results, model version, and expected behavior changes. I also keep rollback options because small wording edits can create regressions. For high-impact workflows, I use feature flags or gradual rollout. Prompt governance becomes essential once multiple teams depend on the same AI behavior. In your answer, talk about treating prompts as code, version control, change logs, test suites, rollback, environment separation, ownership, observability, and linking prompt changes to model changes. Question 16. How do you design prompts that follow safety and compliance requirements? I start by translating safety requirements into clear behavioral rules. What the assistant can answer, must refuse, or should escalate. For regulated domains, I avoid definitive professional advice unless the product is authorized to provide it. I also instruct the model not to expose sensitive data and to use safe alternatives when refusing. Safety prompts should be tested with adversarial cases. The goal is not blanket refusal. It is helpful behavior within approved boundaries. Be sure to mention policy constraints, refusal patterns, safe completion, sensitive data handling, regulated domains, auditability, escalation paths, and balancing helpfulness with risk management. Question 17. What are agentic workflows, and how do prompts change when building agents? Agent workflows let a model plan, call tools, observe results, and continue toward a goal. Prompts for agents need more than task instructions. They need tool rules, stopping conditions, state handling, and error recovery behavior. I define what the agent may do autonomously and what requires confirmation. Logs and intermediate state are important for debugging. The risk is runaway actions, so agents need strict permissions, budgets, and clear success criteria. While answering, cover planning, tool use, state management, task decomposition, stopping criteria, error recovery, autonomy limits, observability, and why agents need stronger guardrails than single-turn prompts. Question 18. When would you use prompt engineering, RAG, or fine-tuning? I use prompt engineering first, when the task can be improved with clearer instructions, examples, or formatting. I use RAG when the model needs current or private knowledge and answers must be grounded in sources. Fine-tuning is better for repeated behavior, domain style, classification patterns, or specialized outputs at scale. These are not mutually exclusive. A strong production system may use fine-tuning for behavior, RAG for facts, and prompts for orchestration. Make sure to cover trade-offs among speed, cost, domain knowledge, style consistency, factual grounding, maintenance, data requirements, and when combining approaches is better than choosing one. Question 19. How do you debug a prompt that works in testing but fails in production? I first compare the exact production prompt, model version, parameters, tools, and context against the test setup. Many failures come from hidden differences, not the prompt alone. Then I collect failing examples, categorize them, and add them to a regression set. I check whether failures are format, reasoning, retrieval, safety, or ambiguity issues. Debugging prompts is empirical. Isolate variables, reproduce the failure, make one change, and measure the effect. In your answer, talk about logging inputs and outputs, model version drift, hidden context differences, user variability, edge cases, sampling settings, regression datasets, and reproducible failure analysis. Question 20. How would you optimize prompts for lower latency and cost? Cost and latency usually track token usage and model size. I shorten instructions, remove redundant examples, cap output length, and retrieve only relevant context. If quality holds, I move simpler tasks to smaller or cheaper models. Caching repeated prompts or retrieval results can help a lot. I also avoid asking for verbose reasoning when the final answer is enough. Optimization must be measured because cutting context too aggressively can reduce accuracy. Be sure to mention token reduction, concise instructions, smaller models, caching, retrieval precision, output length limits, batching, avoiding unnecessary examples, and measuring quality trade-offs. Question 21. How do you ensure structured outputs are both correct and useful for downstream systems? I define the output contract before writing the prompt. Field names, types, required values, enums, and how to represent unknowns. The model should not invent fields or mix explanation into machine-readable values. Downstream systems should validate the response and reject malformed data. I also design for backward compatibility when schemas evolve. If a field is uncertain, I prefer explicit nulls or confidence metadata rather than forcing the model to guess. While answering, cover schemas, enums, required fields, null handling, validation, retries, confidence scores, downstream contracts, backward compatibility, and separating human-readable text from machine-readable fields. Question 22. How would you design a domain-specific assistant such as a legal, medical, or finance assistant. For a domain-specific assistant, I define what it can and cannot do, then ground answers and approve sources. In legal, medical, or finance contexts, I add risk classification, disclaimers, and escalation paths to human experts. The prompt should ask clarifying questions when user intent is incomplete. I also use domain terminology carefully without overstating certainty. Accuracy, auditability, and compliance matter more than sounding conversational in high-stakes domains. Make sure to cover domain boundaries, source grounding, disclaimers, expert review, escalation, terminology, risk classification, compliance rules, user intent clarification, and limitations of model-generated advice. Question 23. What should a prompt do when the user's request is ambiguous? When a request is ambiguous, the prompt should guide the model to either ask a clarifying question or proceed with stated assumptions. The decision depends on risk. For low-risk tasks, like drafting a casual email, assumptions are fine. For high-risk or irreversible actions, the assistant should stop and ask. I like prompts that say, if missing information affects correctness, ask one concise clarification. That keeps the experience helpful without creating fake certainty. In your answer, talk about clarification questions, reasonable assumptions, user experience, task risk, confidence, avoiding premature answers, and when to proceed versus when to stop and ask. Question 24. How would you A/B test two different prompts? I start with a clear hypothesis, such as prompt B improves completion rate without increasing hallucinations. Then I define primary metrics, guardrail metrics, and a fair traffic split. I avoid changing the model, retrieval pipeline, and prompt at the same time because attribution becomes impossible. Quantitative results should be paired with qualitative review of sampled outputs. A/B testing prompts works best when the task has measurable user outcomes, not just internal preference. Be sure to mention hypothesis, traffic split, success metrics, sample size, guardrail metrics, user segmentation, statistical significance, qualitative review, and avoiding simultaneous model or product changes. Question 25. What metrics would you track for a prompt-powered product in production? I track both product and model quality metrics. Product metrics include task completion, user satisfaction, retention, and escalation rate. Model metrics include accuracy, hallucination rate, format validity, refusal correctness, latency, token usage, and cost per successful task. For safety-sensitive systems, I monitor policy violations and near misses. Metrics should be segmented by user type and use case because averages hide failures. Production monitoring is essential because prompts degrade when inputs, users, or models change. While answering, cover task success, user satisfaction, format validity, refusal accuracy, hallucination rate, latency, cost, token usage, escalation rate, safety incidents, and long-term monitoring after deployment. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.